Welcome back to our ongoing exploration of the OEIS, the online encyclopedia of integer sequences. As always, we're taking a deep dive into a sequence you requested. And today, we're focusing on A00000061. Officially generalized tangent numbers, dn1.
Yeah, it's a fascinating sequence, especially for those of you in STEM fields. You might recognize the term tangent, from trigonometry.
Right.
But these generalized tangent numbers kind of take us on a journey beyond those familiar angles and triangles, delving into combinatorics, number theory, and even probability.
Right from the start, the OEIS entry gives us the first few terms. 1, 1, 2, 4, 4, 6, 8. What's the pattern? It's trickier than it looks. And that's what makes this deep dive so intriguing.
Yeah, what's fascinating here is that A000061, it helps us see connections between seemingly unrelated mathematical concepts.
Yeah.
We start with this simple sequence, but it leads us to some pretty deep mathematical waters.
Our sources mention something called alternating permutations. Can you unpack that for us?
Think of it this way. Imagine you have the numbers 1, 2, 3, 4, and 5. An alternating permutation is an arrangement of these numbers where the values alternate going up, then down, then up again. For example, 2, 4, 1, 5, 3 would be one such arrangement.
So a 00000061 is counting these specific arrangements.
Exactly. If you look at the fifth term of our sequence, which is 16, it's telling us there are 16 different alternating permutations for the numbers 1 through 5.
That's a neat connection between a numerical sequence and a combinatorial concept. But it sounds like there's even more to this sequence, right? Our sources also mention something called Dirichlet L-series and the tangent law.
Yeah, these connections really highlight the depth of A000061. Dirichlet L-series are powerful tools used in number theory, and the fact that our sequence is linked to them suggests it has significance beyond just counting arrangements. It hints at a deeper structure within number theory itself.
And the tangent law, that sounds completely unrelated. What's the connection there?
The tangent law is a specific type of probability distribution. And what's amazing is that A000061, which we first encountered in the context of combinatorics, actually emerges in the behavior of random events described by this law.
Wait, so you're saying these tangent numbers can actually predict how random events might unfold? That's wild.
It might sound surprising, but it underscores the interconnected nature of mathematics. Seemingly abstract concepts like generalized tangent numbers can have unexpected applications in understanding randomness and probability. It makes you wonder what other hidden connections are lurking within the OEIS just waiting to be discovered.
Okay, let's take a step back for a second. For our listeners who might be wondering, what are these generalized tangent numbers anyway? Can you give us a bit more context?
Of course. The standard tangent function you might remember from trigonometry is just one specific case. Generalized tangent numbers, as the name suggests, broaden this concept. They introduce parameters that allow us to generate different sequences with specific properties, opening up a whole new world of mathematical possibilities.
So dn1, in the official name, generalized tangent numbers, dn1, is telling us about a specific family within this broader concept.
Precisely. It signifies a particular way of generating these numbers, and understanding these parameters allows mathematicians to explore different families of tangent numbers and their unique characteristics. It's like having a mathematical toolbox where you can adjust the settings to create different tools for different tasks.
And A00000061 is just one tool in that toolbox.
Exactly. And as we've seen, even this one tool has revealed fascinating connections to different areas of mathematics. It makes you appreciate the power and depth of seemingly simple sequences like this one. And for our listeners who might want to explore A00000061 further, the OEIS entry actually provides Python code for generating more terms.
That's great for those who like to get hands-on. You can actually see how the sequence unfolds, and perhaps even find new patterns or connections.
It's a great example of how the OEIS can be a valuable resource for both theoretical exploration and computational investigation. You can delve into the mathematical underpinnings of a sequence and then actually experiment with it using code.
Speaking of exploration, our sources also touch on the historical context of tangent numbers. What can you tell us about that?
Tangent numbers have a rich history, going back to the 18th century, and the work of Leonhard Euler, one of the most prolific mathematicians of all time. He was particularly interested in studying power series expansions of trigonometric functions.
Power series can be pretty complex. Can you give us a simplified explanation of their relevance here?
In essence, a power series represents a function as an infinite sum of terms, each involving a power of the variable. Euler found that when you express trigonometric functions like tangent and secant as power series, These special numbers, we now call tangent numbers,
Huh.
emerge as coefficients.
So tangent numbers were initially discovered through the study of these power series expansions. It sounds like they weren't even the main focus of Euler's work.
Exactly. It's a testament to the interconnectedness of mathematics, that explorations driven by pure curiosity can lead to unexpected discoveries with far-reaching implications. In this case, those tangent numbers that popped up in Euler's power series turned out to have connections to all these other areas of math we've been discussing.
It's fascinating to see how a concept that arose from a seemingly unrelated area like trigonometry can have such a deep impact on other fields.
It really highlights the beauty of mathematics, how these seemingly disparate concepts intertwine in surprising ways. And with that, I think we've covered some of the key insights from our deep dive into A00000061.
We certainly journeyed from the familiar territory of the tangent function to some pretty unexpected destinations, alternating permutations, Dirichlet L-series, even the tangent law, and probability. It really underscores the idea that the OEI is so much more than just a catalog of numbers. It's like a portal to a universe of mathematical connections just waiting to be explored.
Yeah, and A000061, with its humble beginnings in the familiar tangent function, has given us a glimpse of that interconnectedness.
Yeah.
It's a reminder that even seemingly simple sequences can lead to some pretty profound mathematical insights.
For our listeners who are ready to dive even deeper, the OEIS entry for AI000061 provides a list of references with a wealth of information on generalized tangent numbers, their history, and their applications.
Yeah, these resources can be your guide as you embark on your own mathematical journey, tracing the intricate paths that connect trigonometry, combinatorics, number theory, and even probability.
And who knows what other hidden connections you might uncover along the way.
That's the beauty of exploration. Every sequence in the OEIS holds the potential for new discoveries.
So to our listeners, keep those sequence requests coming. We're excited to see where our next deep dive will take us in the vast world of the OEIS. Until then, happy exploring.